All right. For example 2 from your chapter 10, we have questions such as determine the wavelength of an electron then that has been accelerated through a potential difference of 100 volt. So what we have in the question is the potential difference V of an electron. Okay, so the question asks to find lambda. And as we know, there are few equations here for lambda. The basic is the de Broglie wavelength, H over B. However, after you derive, you will get your lambda as H over 2m EV. Okay, so where H here is your Planck constant, 2 is just a number here, m here is the mass of electron, E is the charge of electron, and V here, capital V, is your potential difference. So H constant 6.63 times 10 to the power negative 34. Mass of electron is also constant, 9.1 times 10 to the power negative 31. Charge of electron is another constant here, negative 19. V is given as 100. So you can just put in all the value here and press your calculator. You will get your answer. So 9.11 exponent negative 31 times 1.6 exponent negative 19 times 100 times 2 square root, and then 6.63 exponent negative 34 divided by answer. You should get 1.2279. So we round off to 2 decimal places. So this is your lambda here. We good?
Yes,
Yes,
Miss.
You
Miss.
have to focus on the word electron here. So we know electron has the mass and the charge of electron which is constant lah. So if you forgot, you have to go back and look at the list of constant. Okay. All right. Next, we're going to proceed with the tutorial question. Okay, I'm going to discuss the question with the highest word first. And then if we still have time, we'll look through the other question lah, such as question 3, 5, and so on. So basically, I'm going to start with question 4 first. All right, we have an electron is accelerated from rest through a potential difference of 1250 volt. If the potential difference is half, calculate the ratio of the electron new speed to its original speed and the ratio of electron new wavelength to its original wavelength. Okay, so what we have here is the electron is accelerated from rest. Initially, it was at rest, and then through a potential difference of 1250. So our voltage here, initial voltage, let's say original, is 1250 volt. And then they say that if the potential difference is half, now you have half your potential difference. So after some time, your new potential difference here is half of 1265625 volt. Okay, so you have 625 volt here. The question asks to find the ratio. Okay, ratio of what? New speed. Okay, ini V kecil V new to V original. Okay, you want to know this one. The ratio of V new to V original. Okay, however, you have to bear in your mind, you are given information on potential difference. So, try to find the relationship between the potential difference and the speed in terms of equation lah kan. Right? So, as you can see here in this chapter, we have the understanding that kinetic energy is equals to potential energy. Kinetic energy is half mv square. Okay, in this equation, we have our velocity and then we have EV as our potential energy. So now you can equate, you have half mv square is equals to EV. This part here on the left hand side has the term V that we are looking for. And this part on the right has the term V voltage that we are given. Okay, so rearranging this equation, you will have equation of speed given as 2 EV over m square root. Okay, this derivation is actually also given in the notes. Okay, so kalau betul-betul tak ingat nak derive daripada sini, tak ada masalah. Ini pun ada. So boleh guna terus. This is the equation that is going to relate your velocity and your potential difference. Okay, so since we are going to find the ratio, so simply put in V new over V original akan sama dengan cert 2 charge of electron here. Charge of electron will not change sebab kita tak tukar electron. Particle kita tetap electron. Electron mempunyai charge 1.6 times 10 to the power negative 19 coulomb. This is valid for both the case, new ataupun original. The charge of electron is still the same. The potential difference for the new, kita ada nilai sebanyak 625 and then divided by the mass of electron. Mass of electron is also a constant. So tak kisahlah dalam case terbaru kita ataupun in the original case, we'll have the same mass here. And then you're going to divide with 2E V original over M square root the whole thing. Okay, ataupun kita bawa ke sini, boleh jadikan dia M2E V original gini. Okay, and then as you can see, we have a few constant term here yang sama, so kita boleh cancel lah sebab mass ni akan bahagi dengan yang ini, cert iaitu dia adalah 2EV new square root m begini so dekat sini pun kita ada square root m, so you can cancel the whole thing. Okay, cancel. EV pun sama, not EV, 2E boleh di cancel. Okay, and then you are left with cert of V new multiply with 1 over cert of V original, which is cert V new over V original. Okay, V new kita adalah 1250, V new kita adalah 625, original adalah 1250. And then you can press your calculator. You should get this one lah. Alright. Okay, contoh. Awak tak cancel, tak ada masalah juga. Okay, contoh awak tak cancel. Awak boleh masukkan nilai setiap term. 2 memang nilai. E 1.6 times 10 to the power negative 19 darab dengan 1000, bukan V new adalah 625. Dan bahagi dengan mass of electron. Square rootkan dia. Dapatkan jawapan dulu. And then bahagilah dengan yang V original pula. V original kamu akan dapat cert 2 charge of electron darab dengan 1250. Bahagi dengan mass of electron. You will still end up with the same answer, 0.71. So kalau tak nak cancel pun tak ada masalah, boleh masukkan nilai setiap benda dekat sini. Are we good?
Good, Miss.
Okay, so we are going to use the similar method here to find the ratio of the electron's new wavelength to its original wavelength. Okay, sekarang kita ada lambda lambda yang diminta lah kan, new to original. This is what has been asked in the question. Okay, apa yang kita ada dalam soalan adalah potential difference diberi. Okay, and then we know since the potential difference changes, our velocity pun berubah dekat sini. Betul? So kita ada perubahan dari segi voltage dan juga velocity. And you know the value of your new velocity to the original punya ratio. Okay, so what you can do now adalah you can either find for an equation that is going to relate your lambda dengan V, iaitu potential difference, ataupun your lambda dengan speed dekat sini. Depends lah yang mana kamu nak guna. Okay, alright. Paling obvious adalah kita akan terfikir untuk relate lambda dengan potential difference because the information of potential difference is given in the question lah. V ni kita cari, speed kita cari. So ini memang dah diberi. So the equation that is going to relate the lambda and your potential difference adalah H over 2m EV. Okay, this is our equation that is going to relate the lambda and the potential difference. H is a Planck constant, mass of electron, E adalah charge of electron, semua ni constant. Okay, so lambda new over lambda original akan sama dengan H over 2 mass EV new divide by H over 2 MeV original. Okay, sama juga konsep sebab kita punya H ini semua kita boleh cancel sebab ada common term. Kita kalau nak bawa yang ni naik ke atas pun boleh, bawa ni ke atas and then you can see clearly and then boleh cancel. Okay, this is your max so saya tak naklah nak emphasize banyak. Physics dekat sini adalah just to come up with the equation yang akan relate dia tu je lah. Yang lain semua like literally your max. Okay, cancel your H. Cancel your H. And then you can cancel 2m E. So you're going to left with cert V original over cert V new gamma. Betul. V ori adalah 1250. Kamu akan dapat 1.41. Be good here.
Good,
Awak
Miss.
kena relate dengan equation yang akan kaitkan what is given in the question and with what the question ask lah untuk kita proceed. Sama juga dekat sini kalau awak nak masukkan nilai H, 2ME semua pun boleh, tak ada masalah. Because all the information can be fine because they are constant. So tinggal awak masukkan saja nilai. Nak buat jalan panjang pun boleh, nak buat jalan pendek pun boleh. Awak boleh cari juga lambda new dulu. Iaitu H 6.63 times 10 negative 34 bahagi dengan 2 9.11. Lepas tu darab dengan 625 square root semua ni. Dapatkan jawapan ni dulu. Dan buat ni yang sama untuk original. Bla 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 bla. Dapatkan jawapan dia. Pun boleh, tak ada masalah. And then new over original. Ambil jawapan dekat sini contoh X, sini Y. X over Y. Akan dapat jawapan. Sama juga. Tak ada masalah. Jalan panjang, jalan pendek, tak ada masalah. Yang penting, you know how are you going to reach to the answer. ikut style masing-masing. Sebab some people you have to do step by step. Some people laju sikit, so dia akan macam okay, tiba-tiba dah sampai ke jawapan tu. Tapi yang penting kena introduce the equation that you're going to relate the lambda and the voltage here. Kalau guna velocity pun boleh. Okay, dah relate dua-dua. And then saya dah awak tunjuk yang awak cancel ataupun awak substitute masuk and then you show your final answer. Okay, I'm going to proceed with the next question here. Question 5. So what we have for question 5 here adalah an electron and a proton have the same de Broglie wavelength. So kita punya lambda of electron sama dengan lambda of proton which has greater kinetic energy dekat sini. Okay, since soalan kata the lambda of electron dan proton sama, ini adalah informasi yang diberi. Okay, and then the question asks to find in terms of their kinetic energy, which one will be greater. Dia suruh explain pula. So for that, you're going to find an equation that can relate your lambda and your kinetic energy. Kita tahu lambda, kita ada H over P. Ini yang paling basic de Broglie. And then you have a derivation which leads you to 2mEV. Di mana V ni adalah potential difference, V besar. Okay, so you have Planck constant divided by Z to mass of electron, charge of electron, potential difference. Okay, so now as you can see, we have deduced that K is equals to U. K akan sama dengan EV, di mana EV adalah potential energy. So you have the term E multiplying with the V here. So this is your kinetic energy basically. So you'll come up with an equation such as H over Z 2m K potential, kinetic energy. And this is your lambda. Lepas kita dapat equation ini, kamu tengok kita ada term mass dekat sini. Mass kita ini melibatkan mass of the particle. We have two different type of particle, iaitu electron dan juga proton. Sorry, my bad. Electron dan juga proton, sebab ada dua particle yang berbeza. Dua-dua particle ini akan ada mass yang berlainan. Okay, mass of electron adalah 9.11 times 10 to the power negative 19. Mass of proton, if I'm not mistaken, 1.67 times 10 negative 27 kali. Okay, these are the, ini 31. Okay, these are the mass of electron and proton. They have different mass. Okay, since they have different mass, okay, hanya H dan 2 sahaja constant. M is not a constant here. So nilai M ini akan effect nilai kinetic energy kamu due to your lambda. Since dia kata lambda of electron sama dengan lambda of proton, you will end up with H 2 mass of electron, kinetic energy of electron sama dengan H 2 mass of proton, kinetic energy of proton dekat sini. Okay, kita akan end up with something like this. Okay, so as you can see, your H is constant, kita boleh cancel. 2 pun constant, kita boleh cancel. So what you can do here is, awak pun bawa lah dia jadi 2, 2 tak ada dah. MP KP is equals to ME KE. Alright. Okay, so KP over KE akan sama dengan ME over MP. So daripada sini, as you can see, your kinetic energy are inversely proportional to the mass. K is inversely proportional to the mass of the respective particle. Okay, K is inversely proportional to the respective particles. Therefore, okay, bila mass dia increase, kinetic energy akan decrease. Mass dia decrease, kinetic energy akan increase. So kalau kamu tengok, mass of electron negative 31, mass of proton negative 27. So negative 31 lebih kecil daripada negative 27. Therefore, mass of electron is less than mass of proton. Sebab mass of electron kecil, maka kinetic energy of electron akan besar daripada kinetic energy of proton. So electron will have greater kinetic energy dekat sini. Okay? Faham ke?
Faham, Miss.
Ataupun okay, yang dah faham tak ada masalah, yang masih macam lost tadi kita come up with this equation, betul tak? Okay, lambda mereka sama and we know lambda is equals to H over 2mk. Okay, ini equation yang kaitkan lambda dengan kinetic energy. Since lambda mereka sama, it is not going to affect the value of your kinetic, it is not going to show any relationship dekat sini lah sebab lambda mereka sama. Tapi kalau kamu tengok mass of electron dan mass of proton tidak sama because we are talking about two different particles dekat sini. So what is going to happen now is kita rearrange equation ini, kita akan dapat H square over 2m lambda square. Okay, sebab lambda mereka sama, ini jadi constant. So ini constant. Ini pun constant. Ini pun constant. So your K only depends on your M. Okay, your K only depends on your M in this case because we have the same lambda. So K is inversely proportional to the mass. Okay, ini sebab we are talking about two different particles. Satu elektron, satu lagi proton yang mempunyai mass yang berlainan. Alright, and then sebab dia orang inversely proportional and mass of electron kecil daripada mass of proton, maka kinetic energy of electron akan besar daripada kinetic energy of proton. Okay, so your answer is inilah kinetic energy of electron besar daripada kinetic energy of proton. Kalau kamu tengok dia suruh explain. Okay, explanation kamu adalah this equation basically. Dan relationship yang kamu tunjuk iaitu K is inversely proportional to your M. Okay, these are your explanation. Okay, untuk physics kita tak perlu. It is not necessary to write in sentence. You can show by this equation dekat sini. Next, this will calculate the ratio of the electron's kinetic energy to the kinetic energy of the proton. So kita nak ratio of kinetic energy of electron to the proton. Okay, macam tadi kita tengok, you have deduced this relationship where your K is inversely proportional to your mass. So kalau kita nak cari KE over KP, dia akan jadi mass of proton over mass of electron. Mass of proton adalah 1.67 times 10 to the power negative 27. Mass of electron adalah this much. So kita akan tekan calculator and dapat jawapan yang diberi itulah. Okey ke?
Okay, Miss.
Saya bagi saya bagi 1 minit untuk awak digest dulu. Okay, next we're going to look at question 7. You have the resolving power of a microscope is proportional to the wavelength used. Okay, sebenarnya ayat ini salah sebenarnya. Your resolving power is not proportional to your wavelength. Okay, mereka sebenarnya inversely proportional. Okay, the shorter the wavelength, maksudnya lagi kecil kamu punya wavelength, you are going to get a greater resolving power. Maksud resolving power dekat sini adalah you will be able to see the detail of your whatever kita nak tengok dekat microscope tu dengan lebih jelas. Okay, so they are actually inversely proportional. Cuma apa yang dia nak sampaikan dekat sini adalah they are related directly. Terms that value yang dia bagi untuk wavelength sebenarnya boleh diguna pakai as an resolving power dekat sini. Solution of approximately 1.0 times 10 to the power negative 11 meter ini as kita punya lambda lah kan, sebab dia bagi meter. Okay, unit untuk resolving power adalah A, not dekat atas ni sebenarnya. Okay, so walaupun dia guna a resolution of approximately, ini sebenarnya adalah your wavelength would be required in order to see an atom. Maksudnya with this much of very small lambda, you can see the details at this particular case lah. Sebab dia kata awak akan perlukan, you would require this much untuk tengok the details. If electron were used, what minimum kinetic energy would be required for the electron? So kita nak cari K dekat sini. What is the minimum kinetic energy? Apa yang diberi dalam soalan adalah lambda basically. So equation yang akan kaitkan lambda dan kinetic energy dekat sini adalah K is equals to H over sec 2m K, iaitu this one is actually 2m EV equation ini. Okay, and we know EV ini adalah kinetic energy, so we substitute K and we are going to use this equation lah. Tapi kita nak cari K, betul tak? You can rearrange ataupun boleh masukkan nilai, nanti baru waktu nak darab, nak tekan kalkulator baru kamu bawa ke kiri, bawa ke kanan untuk dapatkan nilai K kamu. Saya dekat sini saya nak rearrange dululah. So my lambda here 2mk square root H over lambda and then 2mk H square over lambda square and then K akan jadi H square over 2m lambda square. Okay, so H is a constant 6.63 exponent negative 34. Mass here we are talking about electron. So dia adalah mass of electron 9.11 times 10 to the power negative 31. And then lambda is given in the question such as 1 exponent negative 11. So boleh tekan calculator untuk dapatkan jawapan kinetic energy kamu. Okay, yang penting adalah you should be able to deduce the equation yang kita nak pakai dekat sini. And then dia kata if photon were used, what minimum photon energy would be needed to obtain this much of resolution. Okay, sebab dia kata photon dekat sini dan dia cakap minimum photon energy. Photon dekat sini if you remember, dalam chapter 9 kita belajar dia adalah cahaya yang datang itu. Okay, so we are talking about that energy, the energy of the light that is going to come. So photon energy equation dia adalah E is equals to HF ataupun HC over lambda. Okay, lambda is given in the question, so you can find your minimum energy of your photon. H constant, C constant, lambda sudah diberi dalam soalan. So you simply put all the value in and press your calculator. You will get the energy of photon. (1.99 times 10 to the power negative 14 joule). Okay, ngam. Alright. Kamu jangan pula pergi guna equation kinetic energy dekat sini. Sebab dia kata minimum photon energy. So sekarang cahaya yang datang, dalam electron microscope tu, kamu tak guna electron lah, you are using photon sebab dia kata if photon were used. So photon itu adalah cahaya yang kita ada mitochondria kita tu. So energy dia adalah HF, Hc over lambda. So you have to always remember your chapter 10, chapter 9, 10 dan 11 ini dia macam berkait lah sikit. Tapi yang paling related adalah chapter 9 and chapter 10 lah. Okay, question 8. You have a photon has a momentum of magnitude of this much. So this is your momentum. Determine the wavelength and the energy of this photon. So kita nak lambda dulu. Lambda equation kita sama saja, iaitu de Broglie wavelength given momentum H over P. Ini adalah de Broglie wavelength and also momentum is given. So kita boleh simply guna equation lah. You don't have to find for the derivation of this lambda in terms of anything else. Macam tadi, kita nak cari kinetic energy, so kita guna yang derive. Okay, sekarang memang momentum is given, so you can simply use this one. 6.63 times 10 to the power negative 34 divided by 8.24 times 10 to the power negative 28. Tekanlah calculator, you should get this answer. And then dia minta photon energy, sama. Sebab dia adalah photon energy, E is equals to HF. F tak ada, HC over lambda. Lambda awak baru je cari dekat atas sini. Okay, so remember, kalau dia guna perkataan photon, kita guna equation yang kita belajar dekat chapter 9 iaitu E is equals to HC over lambda. Saya rasa soalan 7 dengan soalan 8 ni masalah kamu adalah sebab maybe you do not know the ataupun tak terfikirlah nak guna E is equals to HC over lambda ini. Alright, question 9. In Davison-Germer, if Davison and Germer had used 100 volt to accelerate the electron beam instead of 54, what is the wavelength of the electron? Okay, so dia kata if kita guna 100 dan bukan 54, apa wavelength kita dekat sini? Okay, this is very direct juga. So basically kita nak cari lambda. Ini general equation. After you derive, you can have equation of lambda relating to your potential. Sebab potential yang diberi dekat sini. So H over 2 MeV square root. Okay, sebab we are talking about electron dekat sini. Then kita untuk mass dan juga charge akan jadi belonging to the electron. Negative 31. And then ini akan jadi 1.6. Negative 19. 100 lah sebab sekarang we are talking about instead of 54. Kalau dia guna 100. Kita nak cari apa akan jadi kepada wavelength kita. Rather than what you should get. Inilah. I assume there is no problem. Awak akan dapat 0.123 nanometer. And then we have question 10 here. An electron and proton of mass Me and Mp respectively are accelerated from rest by the same potential difference. Okay, so sekarang kita ada dua partikel yang berbeza and we know each of these particles akan ada mass dia tersendiri, mass of electron given as Me, mass of proton given as Mp dekat sini. And then dia kata they are accelerated at the same potential difference. So the potential difference VE of electron dan VP of proton akan sama. Dia kata the de Broglie wavelength for the electron and proton are lambda E and lambda P. Okay, so dia suruh cari what is the ratio in terms of mass. The ratio of the wavelength in terms of the mass dekat sini. Okay, so dekat sini apa yang akan jadi adalah because you are going to find the relationship in terms of mass dekat sini. Kita akan tengok lambda kita is equals to H over P, where your P here, momentum here is given as mv lah kan. Alright. So, from here, lambda of electron akan sama dengan H over mass of electron, velocity of electron. Okay. And then lambda of proton akan sama dengan H over mass of proton, velocity of proton. Okay. Alright. Sekarang, kalau kita tengok informasi yang kita ada adalah on their potential difference, and we know this potential difference can be equate dengan kinetic energy, iaitu kinetic energy sama dengan U sama dengan EV. Okay. So, kinetic energy of electron akan sama electron, voltage of electron. Kinetic energy of proton akan sama dengan EVP. Okay, charge of electron dan proton sama sahaja. Lain sifat sahaja. Charge mereka sama 1.6 exponent negative 19. Okay, also given in the question that they have the same potential dekat sini. Therefore, kita boleh buat conclusion kinetic energy of electron sama dengan kinetic energy of proton. Okay, and general equation yang paling basic untuk kinetic energy adalah half mv square is equals to. So, electron, proton. Okay, so now we are trying to relate this dengan sini. Okay, sebab apa yang kita ada dekat sini adalah daripada yang basic. Okay, dekat sini kita kaitkan dengan informasi yang diberi iaitu potential. So, if you can see, if I were to rearrange this equation, tengok yang color merah ni pula. MEVE akan sama dengan H over lambda E. Okay. And then kita ada MPVP sama dengan H over lambda P. Okay, sebab saya ada term MEVE square dan juga MPVP square ini, apa yang saya akan buat dekat sini adalah saya nak cuba relate this tu lah, because you have the term yang sama dekat sini. Okay. Alright, yang ni sebelum kita further buat apa-apa, half ni kita boleh cancel. So when you cancel, you will end up with MEVE square is equals to MPVP square. Okay, kita nak cari ratio of this one in terms of mass. You have to remember maksudnya term mass tu tak boleh hilang lah. Term mass kena ada dekat sini. Okay, so now you are going to relate these two dekat sini. Okay, so next step apa yang kita akan buat adalah kita akan cuba 1 over ME over MEVE square. Faham ke? Sama dengan 1 over MPVP square. Sebenarnya ini saya tulis balik sebegini. Benda yang sama. Saya squarekan dekat sini. You will end up with ME square VE square. Betul tak? Tapi saya cancel balik dengan ME sini supaya you will end up with MEVE square. Okay, sebab if you were to simply substitute ini dekat sini, kamu akan end up with term V masih. Okay, kita nak relationship between the lambda and the mass. Okay, so kita nak term mass tu yang kekal. Term mass itu yang kena kekal dekat sini. That is why saya try buat begini. Saya rewrite je balik by squaring them and dividing with the mass. Okay, so 1 over ME akan sama dengan MEVE adalah H over lambda E square. 1 over MPVP adalah H over lambda P kita square. So this one datang daripada sini. Okay, so next apa yang kamu boleh buat adalah kamu nak kembangkan dulu boleh h square me lambda e square sama dengan h square mp lambda p square, and then sebab kita nak ratio of the lambda to the mass dekat sini so kita jadikan lambda on one side, mass on the other side. Dia kata ratio of lambda e to lambda p, so lambda e yang kena duduk dekat atas. So saya bawa lambda e ke sana lambda e square over lambda p square. So dekat sini h ni boleh cancel. So me saya kekal, mp saya bawa ke sini. So dia akan jadi mp. So I will end up with lambda e over lambda p is basically square root of mass of proton to the mass of electron. Sampai situ sahaja. Tak payah masukkan nilai sebab dia kata dia nak in terms of mp dan me. Are we good here? Okay ke? Nampak tak apa yang saya buat? The question here is to calculate the de Broglie wavelength of, kita ada dua situasi, satu adalah photon, satu lagi adalah elektron dekat sini. Kalau kamu tengok dia bagi 2.0 keV. Okay, 2.0 keV ini adalah sebenarnya energy of photon. Begitu juga yang bawah ni adalah energy of elektron kamu. So energy of your photon is 2 kilo electron volt. K adalah 10 kuasa 3. EV nak convert pergi joule. Faham ke? So you will end up with 2 darab 1.6 exponent negative 19 eksponen 3, so kamu akan dapat 3.2 times 10 to the power negative 16 joule. This is what you get as your energy of photon. Okay, kita nak cari lambda. Okay, apa kaitan energy of photon dengan lambda? E is equals to hc over lambda. So you have to remember every time kita cakap pasal photon, awak kena relate dengan energy of photon ataupun anything related to the photon lah. E hc over lambda ataupun E is equals to hf. Sebab ini adalah energy khas untuk photon. Okay, so kita nak cari lambda. So energy kita adalah 3.2 times 10 to the power negative 16. H 6.63 times 10 to the power negative 34. C. And then yeah, going to substitute everything into your calculator and then kita boleh dapatkan lambda kita. Kamu akan dapat 6.22 eksponen negatif 10 lah. Okay, kena convert dulu Kalau tak convert tak boleh juga sebab when you're using this equation, your H and your C are in SI unit. H joule second, C ms negative 1. So ini kena dalam unit joule baru boleh dapat your lambda S meter dekat sini sebab ini joule second, ms negative 1, ini joule. Ini kita tahu unit dia adalah meter. So kalau kamu tengok second S negative 1 dah cancel. So M ini akan automatically jadi the unit for your lambda. So you have to cancel your joule. So nak tak nak ini kena dalam unit joule. Jangan lupa convert. Okay, bila next dia suruh cari wavelength of 2.0 keV electron. Okay, apa yang dia bagi dekat sini adalah energy of electron dan dia minta apa wavelength of the electron basically. So when you're talking about electron pula, energy of electron pula, kita kaitkan dengan kinetic energy sebab dia will be accelerated at a certain potential difference. So potential difference ini kita kaitkan dengan kinetic energy. So K kita adalah 2K EV. Konsep yang sama juga, convert pergi joule dulu. So dia akan jadi the same answer as your energy of photon. So you have the same amount of energy for your photon and also electron. Cuma equation untuk cari energy of electron dan energy of proton tidak sama. Okay, dekat sini kita ada lambda is equals to H over P, and then kita derive dia lagi, kamu akan dapat lambda kamu yang akan kaitkan dengan kinetic energy. Sebab energy sekarang kita adalah kinetic energy. So 2mk. This is the equation yang akan kaitkan kinetic energy iaitu energy of electron to the lambda. Yang dekat atas ni hanya untuk photon. Energy of photon relate dengan lambda Hc over lambda. Dekat sini kita rearrange balik this equation, you will get kinetic energy is equals to H square over 2m lambda square. Tak payah rearrange, kita nak cari lambda kan? Sorry. So tinggal masukkan nilai sahaja. Negative 34 and then divide 2 mass of electron 31, kinetic energy is 3.2 times 10, negative 16. Okay, remember to convert your kinetic energy pergi joule dulu. And then you can get this answer given here. 2.75 exponent negative 11 meter.